Hello and welcome to VitoshAcademy for another video where I'm going to show you an example for floating point arithmetics that gives you actually inaccurate results in Excel, or with other words, cases where Excel will be wrong, where actually a, I don't know, 5-year-old, no, let's say 10-year-old would be actually knowing the correct answer. As you see, Microsoft has already written something about it here. And it's not only Microsoft, to be honest. I mean, there is an issue in any programming language. I can show you, for example, like Python. You see like this 0, 3, and then the force. But in Excel, this can be kind of more interesting. So let's open Excel and show you something. I mean, if you have it like this, 0.2, 0.3, and then 0.1 plus 0.2 equals 0.3. It's not visible. Nothing is visible here. You would be thinking, hey, why this guy is wasting my time on the video? Even if we go like this, I guess up to a certain limit, it will not be, everything would be perfect. And yes, so far it looks like I wasted your time, but stay a bit more just to see, like, as example of the flow in Excel. I mean, if we start with 20 and then we say here 0.01, I will even mark this as input. So these are the only things where we will be putting our input. And then we say, okay, here we will have a calculation, and it would be 20 minus 0.1 would be 99, 19.9. And another calculation cell would be 20 minus 99, it would be 0.1, and actually this is expected if we have it like here, x minus y equals z, then if y should be equal to x minus z. This is basic mathematics, or I'll write it here, x minus z like this, and this would be x minus y. Yeah, I mean, this is literally basic mathematics, and you can try it at home. So x minus z, this one should be equal to y. Yeah, that's pretty much how it is. So if I write this equals this, I'll get a false. Yes. What will happen if I remove 0, 1 to 0, 1 to 5? It will suddenly become true. What will happen if I make any real number? It will be true. This is my check cell. And what will happen if I use 0.75? Yeah, it would be true. What will happen if I use 0.2? It would be false. Let's get back to 0.1 where the standard is and the issue is, and take a look why it is false. Okay. So why it is false? Simply, whenever you have a question like this in Excel, you can do the following: click evaluate formula from formulas and click evaluate. Yeah, it is visible somewhere here. It says 0.1. A lot of zeros. 1 is different than 0.1. Yeah, true. The question is, why does it think that A5 is equal to 0.1 and then a lot of other zeros and then 1? Well, that's a great question. And the answer is somewhere in how actually numbers are built in the programming world. Pretty much any number, let's take 19. It can be something like 2 to the power of, let's say, 4. 2 to the power of 4 plus 2 to the power of, let's say, 1. 18. Yeah, plus 2. Okay, probably something like, why I had to take 19, I don't know. I should have taken something easier, but let's see. So 2 to the power of 1 plus 2 to the power of 4 is 18, plus 2 to the power of 0. And this is how our 19 is built. And 18 would be literally this one, but without a 2 to the power of 0. Yeah, 17 would be this one 2 to the power of 4 is 16, and plus 2 to the power of 0. Yeah, something like this. So all the numbers, all the real numbers, they can be expressed like 2 to the power of something plus 2 to the power of something else without a problem. About this beautiful number here, let's say like 125, 0, 125, they are displayed this way, the following way. 1 divided by 2 to the power of something. So 2 to the power of 3 equals 125. So that's why whenever we write 125 here, Excel knows that it can be presented as 1 divided by 2 to the power of something. So no problem here, it would be perfect. I mean, if we double this to 250, then Excel wouldn't have problems. So what's the big deal with 0.1 then? I mean, it's not only 0.1, but let's leave it here, 0.1. The big deal with 0.1 is actually that there is no such number, at least known to the main kind, up to I mean, at least that actually makes sense to be calculated, or I really don't know whether this number exists, but I don't think that it exists because the same error is present in Python, that can say 1 divided by 2 to the power of n plus 2 to the power of something else plus 2 plus 1 divided by 2 to the power of m plus anything else, that can be equal to 0.1. So yeah, that's why we go to this one and we feel a bit sad. So one way that we can go around it is never to use 0.1. I mean, if you have gone to a bank or like paid with a terminal, you would notice that if you have to pay, let's say 23 euros 32, they write 23.32, but you don't pay 2000, you pay the 23.32. It's just without a dot. What happens in the bank software at the end of the time, they simply move like the dots, and they really do it just because of this floating point arithmetics. But if you are not into this, something else that you can do is use the round option, round, and then 2, and also of course round this one, otherwise you're in trouble. And also up to 2 digits, that's perfect. If you're not into rounding, actually another option that you can probably do is use the following file and then account and then use precisions as displayed. With other words, you go to Excel options and here you go to advanced, you scroll down and you're looking for something like when calculating this workbook, then set precision as displayed, and you get some information data will lose permanently accuracy. Well, happens. Let's see whether it would be okay. No. Happens. And evaluate formula. Okay, let's save it because I guess there should be something in the saving part. Okay. Even if we are using precision as displayed, it doesn't work. Going one step further with VBA, it really doesn't work. So the idea of the precision as displayed is probably something else. Anyway, the rounding version works. So round by the second number, and also here round by the second number, and will be perfect. Our comparison will be perfect. So yeah, pretty much that's all. If you ever use 0.1 and in general floating point decimals, just be careful that Excel can do something really unexpected if you are not into advanced mathematics. I mean, it's not advanced mathematics this thing here, but pretty much Just keep it in mind. Okay, thank you for watching and enjoy the rest of your day or night. Bye.